Hello everyone, welcome back to my channel or my tutorial. Today we are going to discuss about the another part of polynomials, that is exercise 2.2 of polynomials. So let us start the exercise. In this exercise, the first main is find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. So before finding the relationship between the zeros and the coefficients, here we have to factorize this quadratic equation first. So let us factorize this equation. So here x square minus 2x, that is we can write this minus 2x as minus 4x and plus 2x and 8 as it is, this minus 8. Now let us separate this as two parts. Here we'll take x as common, that is x into x minus 4. Here 2 as common and this becomes x minus 4. Therefore the factors are x minus 4 and x plus 2. So the value of the equation becomes 0 when we substitute x is equal to 4 and x is equal to minus 2. Now let us combine this, or let us compare this quadratic equation to the standard form of quadratic equation, that is ax square plus bx plus c. Here a is equal to 1 and b is equal to minus 2 and c is equal to minus 8. And let us assume that the value of x as alpha is equal to 4 and again beta is equal to minus 2. Now to verify the relationship between the zeros and the coefficients, let us find the sum of zeros. Let us find the sum of zeros first. Sum of zeros, that is alpha plus beta, is equal to minus b by a. Here minus b is the coefficient of x and a is the coefficient of x square. So here 4 plus of minus 2 is equal to minus of minus 2 divided by 1, because the coefficient of x square is 1 and the coefficient of x is minus 2, and this becomes 2 is equal to 2. And now let us find the product of zeros. So the product of zeros becomes alpha into beta is equal to c by a, that is 4 into minus 2 is equal to minus 8 by 1, which is equal to minus 8 is equal to 8. So this is the relationship between the zeros and the coefficient. Now let us solve the next problem. 4 square minus 4s plus 1. Here you can observe that this equation is in the form of a minus b whole square, that is a square plus b square minus 2ab. Here a is equal to 2s and b is equal to 1. When we expand this equation, it becomes 4a square plus 1 minus 4s. So the factors of this equation are 2s minus 1 whole square is equal to 0. 2s is equal to 1. S is equal to 1 by 2. Here square is there. So the two solutions are 1 by 2 and 1 by 2. Here alpha is equal to 1 by 2 and also beta is also equal to 1 by 2. So by comparing the above equation to the standard form of the quadratic equation ax square plus bx, ax square plus bx plus c, here a is equal to 4 and b is equal to minus 4 and c is equal to 1. So the sum of zeros, here to find the relationship between the zeros and the coefficients, first we have to find the sum of zeros, that is alpha plus beta is equal to minus b by a. Here alpha and beta are the factors of this quadratic equation and b is the coefficient of x, and that is s, and a is the coefficient of x square. Therefore alpha plus beta is equal to 1 by 2 plus 1 by 2, which is equal to minus 4 divided by 4. Half plus half, that is 1 by 2 plus 1 by 2 is equal to 1. Here 4 by 4 minus and 2 minus is plus and 4 by 4 becomes 1. So this is the sum of zeros. Let us find the product of zeros. So alpha into beta is equal to c divided by a. C is the constant and a is the coefficient of s square. So 1 by 2 into 1 by 2 is equal to c is 1 and a is 4. So this becomes 1 by 4 is equal to 1 by 4. So this is the relationship between the sum and product of zeros and the relationship between the coefficient. Now let us jump to the next question, that is 6x square minus 3 minus 7x. We can write this as 6x square minus 7x minus 3. Now we have to factorize this equation first. So here 6 into 3. 6 into 3 is 18. The factors of 18 are 9 and 2. So we can write this quadratic equation as 6x square minus 9x plus 2x minus 3. Let us take 3 as common in this first part. 3x as common. So 3x of x minus 2x minus 3 here, and again here when we take 1 as common, this part becomes 2x minus 3 again. So therefore the factors are 3x plus 1 and 2x minus 3 is equal to 0. Therefore 2x minus 3 is equal to 0. X is equal to 3 by 2. And when we take 3x plus 1 is equal to 0, this becomes x is equal to minus 1 by 3. So here alpha is 3 by 2 and beta is minus 1 by 3. By comparing this quadratic equation to the standard form, we will get a is equal to 6, b is equal to minus 7 and the constant c is equal to minus 3. Now let us verify the relationship between the zeros and coefficient. So the sum of zeros is alpha plus beta is equal to minus b by a. Alpha is 3 by 2 and beta is minus 1 by 3, which is equal to minus 7 by 6. By taking the LCM for 2 and 3, we'll get 9 minus 2 divided by 6 is equal to 7 by 6. So this is equal to 7 by 6 is equal to 7 by 6. Now let us find the product of zeros. So therefore alpha into beta is equal to c by a. Alpha is 3 by 2 and beta is minus 1 by 3. C is minus 3 and a is 6. So this becomes minus 3 by 6 is equal to 3 by 6. Minus 3 by 6 is equal to 3 by 6. Let us cancel these minus, and 3 ones are 3 and 3 2s are 6. That is 1 by 2. This becomes 1 by 2 is equal to 1 by 2. So this is the verification of zeros and coefficient. Now let us solve the next problem, that is 4u square plus 8. Here we don't have a constant term. So 4u square plus 8u plus 0 is equal to 0. Now this becomes 4 into 0 is 0. Now let us factorize this equation. 4u square plus 8u is equal to 0. Let us take 4u as common. The factors are u plus 2 and plus 0, that is 4u plus 0 is equal to 0 and u plus 2 is equal to 0. So the value is u is equal to 0 and u is equal to minus 2. Here alpha is equal to 0 and beta is equal to minus 2. By comparing the above equation to the standard form of quadratic equation, that is ax square plus bx plus c is equal to 0, we get a is equal to 4, b is equal to 8 and c is equal to 0. Now let us verify the relationship between the zeros and the coefficients. Now let us find the sum of zeros first. Is equal to alpha plus beta is equal to minus b by a. Here alpha is 0 plus beta is minus 2, which is equal to, here b is 8 and a is 4. So this becomes 4 ones are 4 and 4 twos are 8. So this becomes here minus b. So I missed the minus here. So minus 2 is equal to minus 2. Now let us find the product of zeros. That means alpha into beta is equal to c divided by a. Alpha into beta is 0 into minus 2 and 0 divided by 1 because c is 0 here. Sorry, 0 divided by 4. This becomes 0 is equal to 0. So this is the verification for the relationship between the zeros and the coefficient. Now let us solve the next problem, t square minus 15. Here you can observe that in this problem we don't have the coefficient of t. Therefore the factors are t square minus 15 is equal to 0. So t square is equal to 15 and t is equal to plus or minus square root of 15, that is t is equal to square root of 15 and t is equal to square root of minus 15. Therefore alpha is equal to square root of 15 and beta is equal to minus square root of 15. By comparing this equation to the standard form, that is ax square plus bx plus c, here a is equal to 1, b is equal to 0 and c is equal to minus 15. Now let us verify the relation between the zeros and the coefficient. So the sum of zeros alpha plus beta is equal to minus b divided by a. Here alpha is square root of 15 and beta is minus square root of 15. Here b is 0 and a is 1. So this becomes square root of 15 minus square root of 15 is equal to 0. 0 is equal to 0. Now let us verify the product of zeros. Therefore Here alpha into beta is equal to C divided by A. Alpha is root 15 into minus of root 15 is equal to C is minus 15 divided by A. Therefore, this becomes minus of square root of 15 whole square is equal to, here A is 1. Okay, here A is 1, that means which is equal to minus 15. So cancelling the square with the square root will get minus 15 is equal to minus 15. So hence this is the verification of relationship between the zeros and the coefficients. Now let us jump to the next problem. 3x square minus x minus 4. Let us find the factors first. Here 4 into 3 is 12. Therefore the factors of 12 are 4 and 3 itself. Now let us find the factors. 3x square minus 4x plus 3x minus 4. By taking x as common in the first part, this becomes 3x minus 4, and here plus 1 as common, 3x, here also it becomes 3x minus 4. Therefore the factors are 3x minus 4 and x plus 1. So therefore x is equal to 4 by 3 and x is equal to minus 1. Here alpha is equal to 4 by 3 and beta is equal to minus 1. By comparing this equation to the standard form of the quadratic equation, we get a is equal to 3, b is equal to minus 1 and c is equal to minus 4. Now let us verify the relationship between the zeros and the coefficients. That means sum of zeros is alpha plus beta is equal to minus b by a. So alpha is 4 by 3 plus beta is minus 1. So this becomes minus b is minus 1. So minus of minus 1 divided by a is 3. So this becomes, by taking 3 as LCM, 4 minus 3 is equal to 1 divided by 3. This becomes 1 by 3 is equal to 1 by 3. Now let us find the product of zeros. Alpha into beta is equal to c divided by a. That is 4 by 3 into minus 1 is equal to c divided by a. That is minus 4 divided by 3. This becomes minus 4 by 3 is equal to minus 4 by 3. So this is the verification of relationship between the zeros and the coefficient. So this finishes the first main of exercise 2.2. In the previous question, we had learned that to verify the relationship between the zeros and the coefficient. In this question, we have to find the quadratic polynomial itself in this equation. That means in this question we have to find the quadratic equation itself. That means here they have given the sum and product of zeros. We have to find the polynomial. So sum of zeros is equal, that is alpha plus beta is equal to minus b divided by a. Here alpha plus beta is 1 by 4, which is equal to minus b by a. That is here minus b is equal to 1. That means b is equal to minus 1 and a is equal to 4. Now the product of zeros, that is alpha into beta is equal to c divided by a. Alpha into beta is, they have given that minus 1, which is equal to c divided by a. We can write this minus 1 as minus 4 divided by 4. The value doesn't change. So minus 4 by 4 is equal to c divided by a. Therefore here the value becomes equal to 4. Well, that is the value of a becomes equal to 4 and the value of c is equal to minus 4. Therefore a is equal to 4, b is equal to minus 1 and c is equal to minus 4. Therefore the quadratic polynomial is ax square plus bx plus c. That means here a is 4x square minus x minus 4 is equal to 0. This is the quadratic polynomial. Now let us, the next problem is root 2 comma 1 by 3. Here the sum of zeros, that is alpha plus beta is equal to root 2 and the product of zeros, that is alpha into beta is equal to 1 divided by 3. Here you can easily say that alpha into beta is equal to 1 by 3, which is equal to c divided by a. But in this part we don't have minus b divided by a. So we are going to multiply this root 2 by, and divide this root 2 by 3 by 3. We'll get 3 root 2 by 3, which is equal to minus b by a. So therefore here the value of a is equal to, here also a is equal to 3 and here also a is equal to 3 and b is equal to minus 3 root 2 and c is equal to 1. Therefore the quadratic polynomial is by comparing to the standard form ax square plus bx plus c, the quadratic polynomial becomes 3x square minus 3 root 2x plus 1. Now let us jump to the next problem. Here alpha plus beta is 0 and alpha into beta is equal to root 5. Let us assume that alpha plus beta is equal to 0 divided by 1, which is equal to minus b divided by a, and alpha into beta is equal to root 5 divided by 1, which is equal to c divided by a. Therefore, here a is equal to 1, b is equal to 0 and c is equal to root 5. Therefore, the quadratic polynomial is ax square, that is x square plus 0 plus root 5 is equal to 0, that is x square plus root 5 is equal to 0. This is the quadratic polynomial. Now let us jump to the next problem is 1, 1. Here alpha plus beta is equal to 1, which is equal to minus b by a. Here we can consider a as 1 and the product of zeros alpha into beta is equal to 1 into 1, which is equal to c by a. That means 1 divided by 1 is equal to c by a. Therefore, the quadratic polynomial is here a is equal to 1 and b is equal to minus 1 and c is equal to 1. Therefore, x square minus x plus 1 is equal to 0 is the quadratic polynomial. Now let us jump to the next problem. Here sum of zeros, that is alpha plus beta is equal to minus 1 by 4, which is equal to minus b by a, and the product of zeros alpha into beta is equal to 1 divided by 4, which is equal to c by a. In this problem we can easily say that a is equal to 4 and b is equal to 1 and c is equal to 1. Therefore, the quadratic polynomial is four x square plus x plus 1 is equal to 0 is the required polynomial. Now let us solve the last problem in this main. Here alpha plus beta is equal to 4 which is equal to minus b by a. We can consider a as 1, and again alpha into beta is equal to 1, which is equal to c by a. So therefore minus b by a is equal to minus 4 divided by 1, and c by a is equal to 1 divided by 1. Therefore the value of a is equal to 1, b is equal to minus 4, and c is equal to 1. Therefore the required polynomial is, therefore the required quadratic polynomial is x square minus 4x plus 1 is equal to 0 is the required polynomial. Thank you very much everyone. Thanks for watching. My videos are available on YouTube and Facebook. So please like, share, subscribe, follow, and don't forget to leave your comments in the comment box. Thank you.